Hello and welcome to this video where we're going to talk about the graphs of exponential functions. So what I've written down is the most basic form of an exponential function, which is y equals a times b to the x. And then on the graph, I have graphed f of x equals 2 to the x, which again is a very basic sort of exponential function. Now, I did this to highlight a couple of properties about the graphs of exponential functions. And so the first thing I want to talk about is domain. Now, domain is that's all the x values of a function. And it's pretty much assumed for most of functions, especially in an algebra class, that your domain is all reals unless there's a reason why it can't be all reals. And that's the thing with these exponential functions, is that if we were to sort of keep on going, zoom out further and further and further, this thing goes off infinitely in both directions. So our domain is definitely all real. But when we take a look at the range, we're going to notice some differences here. Now, range, again, is y. And I'm definitely noticing some spots where the y values are not. Are you? I'm noticing that there's a hard line at the x-axis. So again, if I were to zoom out, it just sort of follows the x-axis. It never actually gets to the x-axis. So our sort of general sort of starting point is that it's going to be y greater than 0. All right? And the thing is, it's not equal to 0 because it'll actually never get to 0. And I can explain that in another video or another time, but essentially that's what we want to understand, is that the domain is all reals, and then our range is probably going to be half of the number line. In this case, it's everything that's above 0, all the positive things. And now, what I want to point out to you is if we go into the graph, or if we go to Desmos and we kind of play around with things here, it's not going to change, or we can change some of the numbers, but only certain kinds of changes will change our domain or range. So, for example, if I let a be 5, and I say 5 times 2 to the x, my domain and range still remain the same. All right? If I maybe, let's get rid of this, let's make this 4. And let's go times. Let's change this to a 3. Same thing. My domain and range hasn't changed at all. All right. But if I want to change my domain or range, what I can do is take that a value and I can make it negative. All right. By making it negative, it has now reflected over the y-axis. And so what I'm going to do is new color. Going to cross out this, and if a is less than 0, aka a negative number, that means that our range is now going to be less than 0. Again, it's not going to equal 0, but it's going to be less than 0. Okay? Our domain, though, is still all real numbers. All right, now let's get back to our first one, and so we can kind of start there again. So 2 to the x. All right, let me clean this up a little bit. So we talked about domain and range. Now I want to talk about growth versus decay. Strong word right there. All right, so growth is going to look like this, and decay is going to look like that. All right. Now, decay happens when b is between 1 and 0. So, for example, let me pick something that's between 1 and 0, aka 1/2. Notice how that changed the shape of my graph. I can pick any fraction I want. So maybe let's make that 6. Whoa. There we go. All right. And then maybe I can go up to, let's say, 5, 6. All right. It changes sort of what it looks like, but nonetheless, it has this general shape right here that I kind of drew into the notes. So anytime we have something between 0 and 1, it's going to be a decaying value. All right. Now, what happens if we put a negative number out there? So let's go -2 times this. It just, again, flips it over the x-axis, and again, we're at the same sort of thing where our domain is still all real numbers, and our range is still less than, y is less than 0. But again, I want to show you sort of what happens when we play around with a and b. All right, so a really controls the range, B controls which way the graph is going to go, whether it's what we'd call growth or decay. All right, final thing I wanted to show you, so let's clean this up again. Let's go back to our friend 2 to the x, is what would happen if we add another thing outside. So let's go to green, make it look all Christmassy. Let's put in a C value. So what this is going to do, this C value, is it shifts, oops, sorry to say the next thing, shifts our Y value. All right, so if I go to the outside and let's just say I put +3, it lifts my graph up 3 units. All right, and so now what that means is that my domain is still going to be all reals, but my range is going to change a little bit. Now instead of being y is greater than 0, it's going to be y is greater than 3 because I shifted it up 3. Now I take that 3, I make it -3. It's going to be greater than -3. That's how it changes my my range. And so hopefully by kind of taking a look at this, like, Desmos graph and kind of looking at the general form, we're able to kind of connect some of these different sort of properties of exponential graphs. The big thing, the big takeaway is that the domain is always all real numbers, and then the range is going to be half of the number plane, usually centered around 0, but as you can see here, it's the half that's above -3, all right? Or if I made this, put a negative sign, or so -4 times that, now it's below -3. It's the half that's below -3. And then you kind of saw what the difference between growth graphs and decay graphs, and you're going to be able to recognize those later on based off of the function that you're given. Ooh, one more thing I wanted to point out here. So now let's make life a little bit easier on us. So let's make that 4. Let's make this like that. Okay, so if we look at the y-intercept tells us what a has to be. Because anytime we let x be 0, we're going to have, so let's make this 3, that's just going to become 1. But our y-intercept is not going to change, no matter what I put in for b. All right, and so that's why we let x equal 0 if we want to try to find out what a is. Now let me change my a value. So let's make it like -3, and tap that. -3, again, I can play around with this, and I can change these. Let's make it 4. It's still at -3. So the y-intercept tells us what our a value is on there. So if you're looking at a graph, that's a good sort of hack for figuring that out. Now where it gets tricky though is if we end up shifting things. So if we go +1, all of a sudden we gotta be like, uh-oh, we gotta find the difference between sort of where the graph sort of flattens out and then kind of, and where that y-intercept is. But that's a problem for later down the road. You're not gonna have to do something that complicated right now at least. Anyways, good luck on your homework or practice, and let me know if you have any questions.